Lots of walking. Lots of conditioning. 2 days. Okay, Brianna, back to you. What are we starting with? 18. Unfortunately,
14.
you cannot drive the golf course.
Why not?
You have to be older to do that.
Like 18?
No, you have to be 18, but he doesn't let you do it.
You have to walk that much?
No, you don't have to walk very much.
It's not much at all. Have you ever been golfing? It's not that much.
All right, so 18, you start out with this rectangle here. Oh, that's not even what I want to do.
No. Okay. I definitely did strict. Pretty strict. Either wing or you have to torch.
You are supposed to come up with a rectangle. Seems like I didn't get this right even still. 10, -2. Does that look like a rectangle?
It's close enough.
It's close enough? Okay. Well, all right. So you're supposed to come up with a rectangle that matches this one right here, but has this as one of the sides. Okay? Any ideas? Anybody? Lizzie? Yeah, the over and the up and the down. Okay, good. So if you look at this, and again, I might have this drawn incorrectly. It seems like I'm at a wrong point here. 6, 4. Is that 6? Okay, I don't know. That seems like it's right. What Lizzie's saying is if you take this point right here, and sort of, can you see that that's going to be match up with this point here?
Yeah.
Like if we took this and rotated it to there, that's how that's going to match up. So to get from this point to the next one, I had to go over 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. Okay? So to get to the next point from this one, since I rotated it, instead of going over 4 and down 6, I'm going to go over 6, 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4. Okay? And then that's going to make that side of the rectangle. Does that make sense?
Yes.
Okay. Then now I can just look at this line in order to make this line here. To get from this point to that point, I went down 1, 2, 3, and over 1, 2, right? And so for this one here, I need to go down 1, 2, 3, and over 1, 2. Okay? And so if I use those as the coordinates of my new points, then when I make this rectangle here, it should look like the original one that we started with. And I feel like I screwed something up here, but we'll just hope that that works out. Okay? So that means that this point is at 5, 9. Yep, that's what they have. And this point here is at 7, 6. So my two missing coordinates are 5, 9, and 7, 6. Okay?
14.
Hold on just a second. Is there another place that we could have drawn this rectangle and had it work? Colton?
The opposite quadrant.
Okay, good. I could have had this side match up with this side over here and then drew my rectangle out in this direction also. And that would have worked as well. Okay? So there's a couple different ways that you can do that. All right? Okay, 14 is a really challenging, really good problem. If anybody in here got this on their own, I would be really, really excited about that because this is pretty tough. It's a tough combination of algebra and geometry.
And you have
Okay.
I'm kidding, I'm sorry. Sorry for that false.
That's okay. I didn't believe you anyway. All right. So what we have is a big rectangle. And the perimeter of the big rectangle, they tell us, is 198 centimeters. And we are trying to figure out the perimeter of one of the 5 congruent rectangles that fits inside. All right? And if you notice, this is not something that I don't think we've talked about this yet, but this one has a little blue H by it in the book. That means there's a hint in the back of the book. Okay? Did anybody look up that hint? Yeah, what does it say, Elizabeth? Do you remember? Don't remember? Does everybody? Oh, she looks for it? She's looking for it. I just didn't know if somebody remembered it also. It was number 14 on page 67.
Label the width of each small rectangle is W and its length is L. The perimeter of the large rectangle is 5W plus 4L equals 198.
Okay, so they're giving you a little hint, thank you, that we're going to use some variables in here. So they're going to call the widths of all the little rectangles W and the lengths of all of them L's. Does that make sense? Okay, as I go around this rectangle, how many W's do I have? 5, so 5W plus, as I go around there, how many L's do I have? 4, so plus 4L equals the perimeter, which is 198, okay? Go ahead, Courtney. Now, normally then we have an equation and we can solve it, but what's the problem with this equation that makes it impossible to solve? Yeah. Right, I have 2 variables. I have a W and I have an L. And so what that means is I need another equation that I can use along with this one to be able to solve the problem. Lizzie, do you have one? Okay, right, I could change these into different letters, but that's still going to give me the same issue. I need to come up with another relationship. Yes?
3W equals 2Y.
Okay, awesome. So if you look at this side right here, you know that that side equals that side right there, right? So since this side has 3 W's in it, and this side has 2 L's in it, what's true about 3W and 2L? They equal each other, okay? So now I have 2 variables, a W and an L, but I also have 2 equations, and so now I can solve that, okay? And so there's a couple of different ways to do this, a little bit of an algebra review here. I think what I'm going to do, I think this might make the most sense, is I'm going to multiply both of these by 2. Can I do that? As long as I do that to both sides, I'm okay, right? So 3W times 2 is 6W, and 2L times 2 is 4L. So if 3W equals 2L, then 6W equals 4L. And so the reason that I did that is because this 4L right here and this 4L right there are the same. Okay? So I can substitute 6W in for that 4L right there. You see why it would be awesome if you were able to get this on your own? This is pretty rough. So I'm going to take this equation right here and I'm going to rewrite it as 5W plus, what can I write instead of 4L now? 6W. And that still equals 198. 5W plus 6W is 11W. And now I have only one variable, so I can solve this by dividing both sides by 11. 198 divided by 11 is 18, okay? So W is 18. So how do I figure out what L is? Multiply it by 3, so she's going to take this equation here and plug 18 in there for W. So 3 times 18 equals 2L, but what is 3 times 18? 54. Okay, so that means that 2L equals 54, so L has to equal 27. Okay, and now we can answer the question. What is the perimeter of one of the 5 congruent rectangles? So this is 27. This side over here is going to be 27. This side is 18. And this side is 18. So if you add all those up, you get what? 90. Okay? So that's pretty rough. That's pretty rough. I mean, you look at that board, look at all that crazy stuff up there. That's worth like, that's Facebook status right there is what I'm trying to say. Okay? Maybe. Or you can take a cute picture of your banana.
That's gonna go viral.
That's going to go viral. That's it. Yeah. All right, anything else? What? 24? Oh, 24. Okay. All right. I apologize for signing this. You can just kind of watch this just for fun. So we're using what? Ruler. Okay, so all the things. And a compass. All right, so we're going to make a regular pentagon. Does anybody, what's a regular pentagon? Let's start with. What's that? Six-sided is incorrect. Your reference is getting worse and worse. What? A house. Okay, 5 sides. Right? Okay, but since it's a regular pentagon, what's true about our house? All the sides are equal. Okay? And so what I'm going to do to start with is I am going to take this compass. I'm going to use it to draw a circle. Okay? And I think now I'm done with that. Okay. So now that I have my circle, the reason I wanted to start with that is because since my, no, that's not what I wanted to do. Since my pentagon has 5 equal sides, I'm going to take and divide this circle up into 5 equal pieces. And then when I connect those pieces, that's going to give me my pentagon. Okay? So that's kind of the strategy here that I'm going with. How many degrees are there in a circle altogether?
360.
360. So if I divide the circle into 5 equal pieces, each piece will be how many degrees? So I'll answer it once. 360 divided by 5 is?
6, 7, 75.
2.
2.
Okay? 72. I'm sure if I gave you like 15 minutes, you would have been able to figure it out. All right, so I'm going to start with this line right here, just randomly. And then I'm going to put my protractor here and measure a 72 degree. I want to make this a little bit bigger. 72 degree angle, something like that. And then I need to rotate this protractor and mark off another 72 degree angle. And then rotate it again. And go another 72 degrees. You get the idea? Smile away, boys. Smile away. Okay, and then if I wanted to, I could rotate it around again, but if I did this correctly, then I should be back at 72 degrees, which I am. Okay, is that my pentagon? No, that's not a pentagon. Can you see where the pentagon is?
Yeah.
Okay, if I now take my straight edge, which is, we're not talking about a lifestyle here, we're talking about a ruler with no marks on it. You get it? Kind of an old school joke. Straight edge didn't seem to last very long. They do?
At least
Okay. Which is why you got my joke.
we're kind of straight edge means like, you know, straight edge.
You'll have to Google it. Okay, anyway, so if I connect,
How should I?
then there is my pentagon. Okay? And it's a regular pentagon because I know that all of these angles are the same, so all those sides are the same, and blah, 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 blah. Okay?
So how do you make that?
You don't, you just say, you write on there, nice drawing, Mr. Aldrich. And then that's, yeah. Give me some words of encouragement. Okay, anything else? 19 and 22. Okay. All right, so for number 19, It told you to cut out 2 scalene triangles. We don't need to cut them out.
Good, because I didn't.
Good job. We'll just draw a scalene triangle. Does that look pretty scalene?
Sure.
And then we're supposed to have 2 of them that are the same. And the first thing that I'm supposed to do is put these together so that they make a kite.
Needs to be a cube.
What's that?
Needs to be a cube.
Oh, man.
I thought it was like.
That kind of looks isosceles. I am struggling. How's that? Close enough?
Yeah.
I don't know what angle that is right there, but I'm going to just hope it's less than 90 and move on. All right, so let's duplicate that. All right, so now I'm going to take those 2 acute scalene triangles and put them together so that they make a kite. How do I do that? Flip one of them over. So, you know. I am going to
Rotate.
flip it over like that. All right, and then what do you say, rotate?
Rotate.
Okay, and there's my kite. Okay, so really they just want you to see that you can make a kite out of 2 scalene triangles. Because since these are duplicates of each other, these 2 sides will be congruent and those 2 sides will be congruent as well. Okay? How would I put them together in a different way for part B to make a parallelogram? Rotate this one. Like that. Okay, close enough. And so now instead of the sides that are right next to each other being congruent, the sides that are across from each other are congruent. And so that makes a little parallelogram for us. Okay? So if you flip it and put them together, you get a kite. If you just rotate it and put them together, you get a parallelogram. All right, and then did you say 21, Brianna? 22. Draw and carefully label a hexagon with exactly 1 line of reflectional symmetry. Anybody get that one? Did you? You want to draw it? Or do you want me to just look at it?
Yeah.
This one right here, that has more than 1 line because I can also go that way, that way, that way. Yeah. So exactly 1 line, only 1. You got it? Okay. You want to come up? You don't need to. Okay, that should work. So this is one way to do it, and I imagine that there's more. Yep. But if you do something like this, then this has a line of symmetry right down the middle. This half and this half are the same, but anywhere else I try and draw a line of symmetry, it's not going to work out. So one easy way to do it is to make it concave. Lauren had the classic hexagon that looks like that, and that does have 1 line of symmetry, but it also has a bunch more, and it wanted exactly 1. So this one will not work. All right? Okay, don't pass it forward. Let's trade them and grade them.
Riley.